So students, let us start the session. So for those who are new to the for those who are new to this program, so I'm Shubhrata Bosak from Power Electronics Laboratory of Department of Electronic Systems Engineering at Indian Institute of Science. And as already planned, as we have been doing before, each session we'll be solving two questions, and I will give you 3 minutes time after I display the question on the screen. And after that, I will be discussing the solution for the question. So let us start with the first question for today. So the first question is a GATE 2014 question which appeared in session 1. So it's a 2-mark question. So it has been told that ft, the small f of t, is a continuous time signal, and capital F of omega is the Fourier transform of this signal ft. Okay, and now we already know what the Fourier transform means. By definition, Fourier transform is given by f of omega is equal to integration of minus infinity to infinity f of t e to the power minus of j omega t dt, right? Now another function g of t has been given to us, which is defined as integration from minus infinity to infinity of the function capital F of u e to the power minus j u of t du. Okay, now you have been asked to find out the relationship between the function small f of t and small g of t. The options given to you are that g of t would be always proportional to f of t, g of t would be proportional to f of t if f of t is a even function, and small g of t would be proportional to f of t only if ft is a sinusoidal function, and g of t would be never be proportional to f of t. These are the 4 options that have been given to you. You are asked to find which of the 4 options would be correct. So now let me give you 3 minutes time to solve the question, and then we will move ahead. So the 3 minutes time that I had given is over. So let us now talk about the solution of this question. So the first thing that must come to a student's mind after looking at the question is to how to write the function f of t in terms of capital F of omega. For that, we need to know the definition of inverse Fourier transform. So in the next slide, I have written the definition of a Fourier transform, which is already given in the question, and I have given the mathematical form of the inverse Fourier transform. That is, small f of t would be written as 1 by 2 pi integration of the limits minus infinity to infinity capital F of omega e to the power j omega t d omega. Okay, this is the definition of the, this is a mathematical definition of the inverse Fourier transform. Now let us do some mathematical manipulations. So now if I replace t with minus of t, what we are going to get is, so now if we replace t with minus of t, what we are going to get is 1 by 2 pi integration from the limits minus infinity to infinity capital F of omega e to the power minus of j omega. So you see I have replaced t over here with minus of t. Okay, so this is the expression that you get for f of minus of t. Now let us multiply that with 2 pi. So this 2 pi goes away. So 2 pi into f of minus of t becomes integration within the limits minus infinity to infinity capital F of omega e to the power minus j omega t d omega. Okay. Now see, as we've already found in the previous slide, 2 pi of small f of minus t is the function which is being displayed on the slide. That is integration from the limits minus infinity to infinity capital F of omega e to the power minus j omega t d omega, right? And we have been given that, just give me a minute. মামি আমি একটু পরে কথা বলছি, আমি তো ক্লাসে আছি। So now in the question we have been given that small g of t is integration from the limits minus infinity to infinity f of capital F of u e to the power minus j ut du. So you see now these two functions looks quite similar to us, right? So we can say that small g of t is equal to 2 pi f of minus t. Now we have been asked to find relationship between gt and f of t, right? Not f of minus t. So when can we write f of minus t equal to f of t? That is going to happen only when f of t is a even function. So if f of t is an even function, then f of t is equal to f of minus t, and in that case we can write gt is equal to 2 pi f of t. So now we can say that gt is directly proportional to f of t. So this proportionality will hold only when f of t is a even function. So the correct option would be B. Okay, so now let us move on to the next question. Okay, so this is the next question. Op-amp circuit has been given to you, and you have been asked to find the relationship, the output voltage V0 in terms of V1 and V2, and the options has been given to you. That is, option A is V1 minus V2, option B is V1 minus V2 divided by 2, option C is 2 into V1 minus V2, and option D is V1 plus V2. So again, I will give you 3 minutes time to solve the question. After 3 minutes are over, I will ask you the answer, and then we'll move ahead with the solution of the question. So 3 minutes time that I'd given you is up. Anybody with the answer? There is Amruta. Are you there? Are you there, Amruta? Have you tried to solve the question?
Hello.
Hello. Have you tried to
Uh,
solve the? Yes. Yes.
sorry, sorry, you were telling something.
Yes. Have you tried to solve the question?
Sir, actually, I'm not a student. I'm from NPTEL, sir.
Okay, I'm sorry. I'm sorry. Okay, so nobody has joined today. Actually, there was a rescheduling of the class. Actually, my father had surgery on 9th
Okay, okay,
of
okay,
Friday, so
okay.
there was a reschedule of the class. So I couldn't take the class on 9th. I'm taking the class on Sunday, but as there is a reschedule, as there was a reschedule planned, so nobody has shown up today.
Probably, sir. We have mentioned it on the portal also, sir, that the Friday session was rescheduled today, but I guess nobody noticed that.
Yeah, yeah. It's okay. It's okay. So I will be. I'm taking the class on my own. It is being recorded.
Okay,
So once that is
okay,
recorded, I will send the solution. Okay. Thank you.
okay, sir. Okay, thank you, sir.
So okay.
Uh,
So
uh,
as a yes.
shall I leave, sir?
Yeah, you can leave. I'm recording it. You can leave it.
Okay, sir. Okay, thank you, sir.
Yeah. So an op-amp circuit, as I've told, was given to us. So what we are going to do is the first thing that we have to keep in mind while solving this kind of sum is how to apply the virtual ground concept in this kind of sum. So let us move to the solution and discuss the solution. So by the concept of virtual grounding, as the op-amps that we are talking about in this question are ideal, the op-amps have a infinite gain, as a result of which the potential at this point and the potential at the positive and the negative terminal of the op-amps are same. As a result, the potential at point A would be V2 and the potential at point B would be V1. Therefore, as the potential at point A and B are known to us, that is given to us in the question, that is V1 and V2, so we can quantify or mathematically write the equation for the current I. That is, the potential at point A minus potential at, sorry, this would be potential at point B minus potential at point A, because current flows from higher potential to lower potential, divided by 2R. Okay, so in that case I would be V1 minus V2 divided by 2R. So now the potential at point C would be V2 minus of IR, because again C2 must be at a lower potential as compared to VA, because the current is flowing from the current direction that we have chosen from point A to point C. So V of C would be V2 minus of I into R. So V2 would be V2 minus V1 minus V2 divided by 2. So you get the expression for VC as shown on the slide. Again, the potential at D, similarly we are using the same method to find the expression for potential at point D. So in that case, the potential at D would be V1, that is potential at point B, plus I into R, because the current, again as I have told, we have assumed the current is flowing from point D to point A. So D is at a higher potential, as a result of which we can write Vd equal to V1 plus the potential drop across this resistance R. So the expression for Vd would be 3 by 2 V1 minus V2 divided by 2. So now after having found the potential at C and D, we can simply use the superposition theorem and find the potential at the output, that is point V0, the output voltage V0. So we can directly write that the V0 the potential at the output of the op amp would be Vd divided by 2 into 1 plus R, because you see the potential at this point would be Vd by 2. You can use the Thevenin's theorem for that. Potential at this point would be Vd by 2, as op-amp offers infinite impedance to the input. That is, op-amp has infinite input impedance, so no current will be flowing to the device. So the potential at this point would be VD by 2, and if there is a potential of VD by 2 at the positive terminal and we have a negative feedback, then the gain V0 would be given by VD by 2 into 1 plus RF, that is R, that is the feedback resistance R, divided by this resistance R. As we are applying superposition, we have assumed that the potential at C is not assumed, we have taken that potential at C is 0. We have rounded that because we are using superposition. We will consider each input at a time. So first we are talking about the potential at the point D. After having found out the potential due to the potential at point D, now let us find what effect would the potential at C have at the output of the op-amp. So again we will say that the D is grounded. If D is grounded, we have only the terminal C, which has a voltage V of C, as the expression has been written over here. So in that case we can write, so V of C would be minus of RF by R. The feedback resistance is R, so the RF is R, so R by this input resistance R, so R. In that case, so if we solve this, we will get VD minus VC. So VD minus VC, you have got these two expressions. If you subtract that, you are going to get the expression like this. So the correct option is C. So these were the two questions that we had planned to solve. So let us put an end to this session today, and we will meet again on Friday. Thank you.